Okay, welcome to 5.2 part 2. So I guess the video says B over here, so it would be 5.2b. So in this lesson, what we're going to be doing is looking at existing graphs and making the equations out of it. So this is actually part A. We're going to be examining this graph, and they didn't even give us very much of the graph, and we're going to figure out what the formula is. And for each of the questions, you can choose whether you want to answer in terms of sine or in cos. For most of the examples, I'm going to actually do them both for you, and hopefully you'll see that sometimes one of them is clearly easier than the other, and so if you got the option, you'll see how to do that. Looks like I've got a little typo there on function for sine. I should put a t in there. Here, I'll just write it in, so put a t right there. Okay, so looking at our first one, the A value is how we figure out the amplitude. Specifically, it's the absolute value of A, which is equal to amplitude. And most of the time, we're going to keep A positive, and if we need to shift things around, we'll use the C value rather than putting it negative. But I think there's going to be one example coming up where I'll show you how to make the A value negative, and we'll do a reflection. So A is the amplitude. Let's go down here and take a look at our particular example for the amplitude. So the amplitude, well, if we look at the maximum, which is 6 here, so that's this here, and the minimum, which is -4, this whole range here is going to be twice the amplitude. So mathematically, that would be 6 minus -4. And then half of it, because that would be twice the amplitude. So in our example, we're going to get 10 divided by 2 is 5. So we're going to get an amplitude of 5, so an A value of 5. So what are the calculations we just did? Well, we said it's the maximum minus the minimum divided by 2 is what gives you your A. Okay, and so in our example here we have an A is equal to 5. What is your D? We've had a long version here. It's the horizontal central axis, or as I mentioned in class, we could call it the middle. So much easier. And I'm not sure if we always have to do a formula on this one, because this one, it's fairly straightforward. Again, is you say, okay, it's halfway in between here. Right? So if you've already got the amplitude, you can say, oh, well, 5 is the amplitude. I can take from the maximum and go down 5 to 1. Right? So my D is equal to 1. I'll put it over here. D is equal to 1. That's one way to do it. So you could take the maximum minus A. You could take the minimum plus A. You could also say, what's the average of these two values? In which case it would be maximum plus minimum divided by 2. So there's many different ways. I'll put here. I'll put that last one here. I'll put, say, max plus min divided by 2. And in our case, what was the answer again? I forget. Oh, it was 1. So D is equal to 1. All right. The only thing about trying to memorize max minus min, max, they seem so close that you might just mix them up. But really, if you have a sense what amplitude means and what the D value means, if you were the physics student in grade 11, this could also be called equilibrium. Means the same thing. So it's the middle. So you average them. So how do you average? You add the two numbers and divide by 2. So you can think of that. All right. So period. Period is how long it goes for one complete revolution, one complete cycle, and they didn't give us a whole cycle here, did they? So here we've got this spot here. If I draw this kind of a dot across, that's where my axis is. So it goes from here, and this would be my next key point. That would be my next key point. So in our question here, the horizontal distance from there to there, that horizontal distance, that represents what portion of the entire period. So there's the jump from one key point to the next key point is a quarter of a cycle. So that's 1/4 of a cycle, that's 2/4 of a cycle, or that's half of a cycle, half of a period. So I can say in this case, we can say 1/2 of a period is this distance. And what is that distance? It's from 0 to 2. Okay, does that make sense? So I'm thinking, okay, from here to here, if I was to do, sort of sketch out the entire, how big the graph looks, this would be the next place, right? So from here to here is the entire, that would be an entire period. This is half the period, okay? So mathematically, how do you solve for this? Think of period as just like an x or, any kind of a variable. We have to undo the half. So the half is multiplying, so we do the reciprocal. We're going to multiply both sides by 2. So in other words, period is equal to 4, okay? Half of 4 is equal to 2. All right, so how would we say, what are the calculations that you do for period? I guess really what we can just think of is sometimes if you look at the shape of the graph and you look at the key points, right? Each interval is equal to a quarter of a period. And that is sometimes enough information for you to figure out the period. In fact, this was more complicated than most of the time. Usually they'll show an entire period, in which case you can just say, what's the distance from here to here? Okay, so that's how you figure out period. In our case then, what was the period? Period was equal to 4. For b, so b is this part in our equation. The b is related to period. And remember before we said that the period was equal to 2 pi over b. Well, if I multiply both sides by b and if I divide both sides by period, rearrange to solve for b, I get b is equal to 2 pi divided by the period. So in our case here, it's going to be equal to 2 pi divided by 4, so it's pi over 2 will be our b value. All right, so we're almost there. Now we've got the sine function and the cos function. So what does the sine function look like? The sine function looks like it starts at the d value. It starts at this the middle or the horizontal central axis, and then it goes up. So what you want to do to figure out the sine function is if it starts, so I'm going to draw another horizontal axis. If it starts somewhere else, let's say if it starts here and then goes up. All right, so I'll draw this part so it comes down. You want to find the first place where the sine function is starting. I'm going to switch to a different color here. You want to find out the first place where the sine is starting. So just like how sine normally starts. So sine usually starts like there, right? And then this distance to the right, that value right there will be c. Okay, and if it's going to the right, it's a positive c. If it's going to the left, it's a negative c. You don't have to worry about doing the opposite sign because that's taken care of because we're subtracting in here. So we want to find out what the c value is. So this would be positive c. And most of the time I would recommend is just make that arrow to the right and then make it a positive c. Okay, so how could we write that? Find the start of the sine function. Find start of sine function. Right equals a positive c. And left, if you need to, would be equal to a negative c. Well, let's try this function over here. So we have so far an a of 5, a d of 1, and a b of pi over 2. So if I go and take a look at this, I've got an a of 5, a d of 1, and a b of pi over 2. And so far I haven't entered any c value. And so that's what my black curve is here, my nice sinusoidal function, and you'll notice it does look like sine. Okay, now it doesn't start at the origin and go up. It starts at that horizontal central axis and goes up. So, disregard this axis for the next little while. It's going to take a little bit of training on your part to don't think of the x-axis as being the central horizontal axis. Sort of blot that out, and you can actually put in with a dash a pencil in there, and then the only thing as I've suggested is do erase that afterwards as your final answer, so otherwise the marker might think that you think that that's part of the answer. So you can dash that in there and then refer to it. Okay, so what we want is we want to move our C value, and notice as I move C positive it goes to the right, and as I move C negative it goes to the left. So return it back to 0. Where do we want it to be? Well, we want it, so looking back, scrolling down, we want the beginning of sine, well, we want it to be way over here, don't we? So where would that be? Our scale goes 1, 2, that would be at 3. Okay, so we want to move C to the right 3. Okay, so if we go over here, and I will move C to the right 3, and there we go. So now it looks right. Now we've got what we want because we have this exact same shape, right? Maximum's over there. So in our case, if we wanted to do it as sine, maybe I'll switch to blue here. I'll do both. As for my sine value, I'm going to say that C is equal to 3. So following this pattern, I'll have y is equal to, my a value is 5 multiplied by the sine of, now by pardon me, my b value was, what was it, pi over 2 multiplied by x minus my c value, which is 3, plus my d value, which is 1. So there we go. If I were to extend this line to the left over here, I could go and say, hey, I think that's going to cross somewhere over here, and I could actually have a negative c value, but I'm going to stick with that. Now what about cos? So looking back in our chart, for sine, we looked for the start of the sine function. For this one, you guessed it, we're going to look for the start of the cos function. So how does cos look? So if that is my y-axis and that is my horizontal central axis, I'm not going to call it x because it's whatever my d value is. Cos starts from a maximum and then comes down afterwards. Okay, so that's what it looks like. So what we want to look in our function is, okay, so let's say we had a function that started somewhere else. I don't know, maybe it was kind of going like this. We would look for the first maximum, and then that would be our c value. Okay, so for our notes we can write find start of cos. And again, start of cos, and we'll just put in here maximum, because the cos starts at a maximum. Right, we're going to have a positive c. So in this case, we could have a c that goes all the way over to the right, or in fact, it actually starts at a maximum, doesn't it? So the cos c could be equal to 0, and so we would write y is equal to 5 times the cos, and then everything else stays the same. My b value is still pi over 2, but now I don't have to write minus 0, so I can just put an x in there. Make sure I got the right number of brackets, plus 1. Let's go check it out. Let's see if Desmos agrees with us. So we'll have to do two things. We'll have to change this to cos. Cos. There we go. And now we had to change our c value to 0. There we go. And let's see, I've got the old one. See, it's the same. If I put that orange one on top, it changes the color. So it is in fact the same. So we did the first one well. Okay, let's try the other examples. Turn my page as well. So turning to the next page, we're going to walk through and do the same things. We're going to figure out what our letters are, and then we're going to make a sine and a cos version of each of these ones. So first of all, where is the d value? I bet you can look at it and just figure it out right away. Well, if the top's -1 and the bottom's -7, it's halfway in between, and it's pretty clear that this is our d value, right? So I'll put a little dashed line in there. My d is going to be equal to -4. But if you're worried maybe that you're just guessing a little bit wrong, you're nervous on a test, you can say, oh, it's the average of those two numbers. So it's the same thing as adding the two together and then dividing by 2. So adding the numbers together is -8 divided by 2 is equal to -4. So there's a little confirmation. What's my amplitude? So how far away? The amplitude is going to be equal to, well, the amplitude would be that value right there. So how much does it go up? It goes up 3. Cool. What about the period? What's the period in this case? The period, well, it starts here, and you know what, if it's a little confusing to figure out where does it start repeating, just carry on in the path a little bit, and then you'll realize, hey, this starts from the horizontal axis and then goes downwards, and that's the same thing at that point right there. So my period is actually from here to here, so it's going to be equal to 2. Alright, so then my b value is 2 pi divided by the period. So it's 2 pi divided by 2, which is equal to pi. We're almost done. All we got to do is think about our c values. So I'm going to do this twice. We're going to do a version for sine, and we'll do a version for cos. Okay, so remember for sine, what we're looking for is, well, how does sine look? Sine starts at the horizontal central axis and then goes up from it, right? That's what it looks like. So we're going to look for the beginning of that. Seems to me here is the beginning of that. So when we're doing sine, this will be our c value. And what is that? That's 1. So c is equal to 1. And then so we can write our equation here. We can say y is equal to, put the a first, 3 multiplied by the sine of, now we bring out our b value, which was pi, x minus c, which is 1. We should really put brackets around here too, minus 4. Okay, so how about our cos? Cos is, well, remember how cos works? It starts at a maximum and then comes downwards, right? So we're looking for the first maximum. So here is a maximum right there. That looks like it's halfway between 1 and 2. I think we can trust it. So in this case, if we're going to use cos, my c value is going to be equal to 1.5. So I can say y is equal to, everything stays the same here, except I change sine to cos. And now I say x minus 1.5 minus 4. Oh, I'm losing off to the side. Okay, this is minus 4, by the way. Okay, I just want to make a little note. Before I mentioned that we typically leave a as positive, but sometimes it actually makes things easier if you make it negative. And some of you might say, hey, this looks exactly like sine, except it's reflected, right? So what you can do is we could say, or if we take sine, oh, I need a little thicker. If we make sine and we make this a -3, that will do the reflection for us, and then we don't have to have, we can have a is equal to -3, and then c would be equal to 0, because we wouldn't have to have any shift at all. Because when it's reflected, sine starts from the horizontal axis and then goes downwards right away, and that's exactly what this graph does. So here is another option. We could say sine pi x minus 4. That's kind of neat. So it's kind of straightforward there. Okay, let's go on to part C. Oh, kind of scary. They don't even give us a graph. Well, maybe we can make a graph out of the information we have. It says this point is a maximum of a sinusoidal function. Sinusoidal means we can use sine or cos. The next maximum occurs at this point. So some of you might be able to look at those and sort of imagine what it looks like in your head. I'm the kind of person who likes to draw it out a little bit. It's kind of hard to do a good job drawing this out, but I'll try. So the first point is at -2, 7. So it seems to me that I'm going to have to go negative a little bit. So I'll say this one is -2, and I'll say up here is 7, And so that is my first point, and that is a maximum. So there's a maximum, and it's going to be curving downwards after that, so it's going to have a little bit of this shape. And then the next maximum occurs at 6, comma 7. So there, here's 6. It makes sense that it is again at 7, so that these values are the same because they're both maximums. So it's going to be, doing a bit of that curve. The range of the function, so the range is all the possible y values, is the smallest that the y value gets is -1, and the highest it gets is 7. So I don't know exactly what it's going to look like, but like halfway in between, it's going to be at this minimum, right? So it's going to be something like this of a shape. Okay, put little arrows on there as well. So just know, drawing a graph, nowhere in the question does it say you have to draw a graph, but I think it is kind of useful. All right. Now let's do what we normally did. So my A and my D values. Okay. Well, maybe the D is the easiest. So what's halfway between 7 and -1? They're 8 apart, right? So halfway in between, if I subtract 4 from here, I think it would be 3. So in fact, I will draw my dashed line at 3, and A is going to be equal to 4. Let's just try it out. 3 plus 4 is 7, 3 minus 4 is -1. Looks good. Okay. Now it says that, now we should figure out what B is and what period is. So we have a period. Well, if they told me that one maximum occurs here at -2 and another maximum of 6, so from maximum to maximum, this length here would be equal to the period. Is equal to, and how far is it from -2 to 6? That is a length of 8. So the period is 8, and my B value is going to be equal to 2 pi divided by 8, which is pi over 4. Okay, now we need to figure out, the last thing is my C. So depending on whether I'm going to use sine or cos. Tell you what, why don't we do sine first in green, we'll do cos in a different one. So sine starts from the horizontal axis and then moves up from it. So this would be the first place where I see the start of the sine function, because it's starting from the axis and then going upwards. So this is my C value there. So C equals question mark. I don't really know how far that is, so I have to sort of think about this a little bit. Okay, so my entire period is 8 long, so each one of these jumps from maximum to middle to minimum to middle, each one of those jumps is going to be a quarter of the period. So these intervals is going to be equal to the period divided by 4, and my period was 8. So each one of these jumps is 2, so it's kind of a friendly graph, isn't it? From -2, so this actually hits right there. I'll put some red dots here. This hits right there at 0. This spot here hits at 2, and so this spot here hits at 4. And it makes sense because then that one will hit at 6. So that my C value is going to be 4. Great. Now that was for sine. That was C equals 4. Now let's switch to blue and we'll do cos. Cos in blue. Okay, so cos we're looking for, where is a maximum? Here is a maximum right there. So in cos, C would be equal to 6. Or you could go -2, couldn't you? You could go left and you could say -2. C is equal to -6. Or another one you could, +6. Or you could say C equals -2. I usually like to go positive just to keep things simple. Alright, so writing it out then, my cos version would be y is equal to A, which is 4, multiplied by, I'm doing cos first, so I'll say cos. The B value is pi over 4. I'm going to run out of room again. Pi over 4 multiplied by x minus 6, and then plus my d, which is 3. And really, I should put another set of brackets around there. Okay. For sine, it would be y is equal to 4 times the sine of pi over 4 x minus 4 plus 3. Okay. We're going to do just this one last example, I think, and then I know there are more printed on your worksheet, but just in the interest of brevity, of keeping things short, I'll do those ones, and then you'll have more time to practice some of the textbook ones. All right, so for this question here, starting off, we've got a maximum at -1 and a minimum at 5. This whole stretch is a stretch of 4, so halfway in between right there. I'll put that in with a dash. So right away I know that my d value is going to be equal to -3. My a will be equal to 2. Now to consider a period. From here to here is an entire period, but that's a bit of a pain because I don't know exactly where that is. Okay, I do know what this spot is, and I know what this spot is. Okay, so I can figure out that mathematically, right? But I also need to know that in terms of period, how many periods that is. Okay, so actually looking at the numbers, this is a crazy question because I've got decimals and then I got pi over 2's. So I'm thinking some rounding happened. If this is pi over 2, clearly this is supposed to be pi over 4. So let's just make a little switch here. Let's call this pi over 4. This would be 3 pi over 4. This would be minus pi over 4. Okay, so then that's a little bit easier. All right, so I guess if I know this stretch from here, I'm going to try to make a straight line. We'll see how we do. Okay, that's not bad, hey? So that stretch there, I want to know it in two ways, and I'm going to say that the two are equal. One is I want to say what's the distance in terms of from negative pi over 4 to 3 pi over 4. Hey, I know what that is. It's pi over 4 plus 3 pi over 4. That's 4 pi over 4. That's pi. So this distance is pi. But how many periods is that? Well, it's a full period, and then it's 2 more of these intervals that I keep talking about. 2 more of these, and each interval again is a quarter of a period. So it's a 1 full period plus another half of a period. So in other words, this is going to be 2 3/2 of a period. You could write it as 1.5, but it is a little bit better, you'll see in a second, to write it as 3 over 2. So just again, if I'm starting from here, and I'm going to say, okay, let's think about where the key points are. They go from like max to here's a key point, here's a key point, here's a key point, there, there, and there. Each jump is a jump of a quarter of a period. So 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters, or 3/2. Okay. So can I solve for period? So period 3/2 of a period is equal to pi. How do we get period by itself? How do I undo that? Well, really what we do is we multiply both sides by the reciprocal of this. So if I multiply this by 2 over 3 times 2 over 3, this turns into 1, turns into 6 over 6. So my next line would be period is equal to 2 pi over 3. So there's my period. My b value, again, is 2 pi divided by the period. Oh no, scary looking fraction work coming up. I think we can do it. 2 pi divided by, we'll make this one bigger. Okay, 2 pi divided by 2 pi over 3. So how do you do that when you're dividing by a fraction? It's the same thing as saying 2 pi multiplied by this reciprocal, 3 over 2 pi. And my 2 pi's cancel out, and so my b value is going to be equal to 3. Did I do that right? I think I did. Okay. Okay, so my b value is equal to 3, and then my c value is my last one. Okay, so my c value, you know what? It's so much easier to do sine than it is to do cos. So I'm just again, in the interest of keeping this short, because it seems to be a little bit more appreciated when I can do it that way. There's the beginning of the sine behavior, where it starts from this horizontal axis and starts up. And that is easy to figure out. So my c here is going to be equal to pi over 4 when I'm using sine. Pi over 4. So let's make my statement here. Y is going to be equal to the a value of 2 multiplied by the sine of b value, which is 3, multiplied by x minus c plus my d, which is minus 3. And I should put brackets around this sine function over there. And there's my answer. Okay, so just looking ahead, if I can, come on. I'm going to not go over these questions. Later on, if you guys want extra help, what I could do is make an extra video of showing those. But I think I've done enough. Your homework are these pages here on page 250. Just a couple notes. One is that question number 10. They want you to find an answer, and then they want you to check by graphing. So the check by graphing, you should graph using some type of technology. So if you have a computer, you can use Desmos, or you can use GeoGebra. If you have a TI-83, you can graph using that. And the other thing is I know that these are quite a few questions, but I would say these are more of the warm-up questions, and don't tire out and avoid these ones. So these are the most important ones. Okay, so muy importante. Okay, very important, those ones over there. And thank you, and I will see you guys in